Hi, my name is David Steele. I'm a product manager at Arcturus. In previous videos, I've demonstrated how you can unpack, set up, and configure the uCMK60-VoIP board and module. I've also discussed how you can integrate it into an overall system by using the dedicated I/O control interface. Today, what I want to talk to you about are some of the more advanced integration options that are available using the Mbarx M2M protocol and interface. If you haven't watched the previous videos, I suggest you might want to check those out first. That way you'll be a little bit more familiar with the overall system. The uCMK60 supports two operating modes. It supports an autonomous operating mode and a controlled operating mode. In another video, I've covered off the autonomous operating mode. Today, I'm going to talk specifically about the controlled operating mode. This mode is intended for applications that need to be supervised or controlled by a remote host. The host can be connected to the device either using a TCP/IP-based socket connection or over a serial UART. Now, it's important to understand the distinction between supervision and control. In our vocabulary, supervision is a passive activity where the host monitors the device while the device behaves autonomously. Controlled mode behaves differently. In controlled mode, if an input button is pressed, the event notification is transmitted back to the remote host, and the host decides what action should be taken and communicates that back to the device. This uses the Mbarx M2M protocol. This is a bidirectional protocol. It supports both operational functions and also configuration functions, and a full specification is available from our dedicated support site. So I want to give you a quick demo of how this all works, and so I've got just my standard network set up. It's standalone. I've just got a little router here that's serving DHCP and providing network connectivity, my laptop, an IP phone, and the uCMK60 System Solutions board. Now what I need to do is I need to configure the uCMK60 System Solutions board into controlled operating mode, and I do that by using the System Manager tool on my laptop. So why don't I go ahead and I'll do that. This is the System Manager tool. It's used to detect and configure uCMK60 devices. I see my device right here, so I'm just going to double click on it, and it's going to bring up the configuration interface. And what I want to do to change my device from autonomous to controlled mode is I just want to go over to the control tab, and I just want to drop down and change that mode over to controlled. And then I'm just going to go ahead and apply that setting. And now the device will restart, and it will expect to have a host application connect to it. And until that host application connects, it's going to show an alarm signal is active. Now, to show you how the Mbarx M2M protocol works, I'm going to use a different application called the Mbarx Virtual Control Panel, which I'm going to open up now. So this is the Mbarx Virtual Control Panel. This application is available for Windows or Mac, and it's intended as a reference to help develop custom applications and support system-level integration using the uCMK60. You can download the Virtual Control Panel from the support site. The app itself is implemented using Qt and Python. Qt is a very widely deployed cross-platform UI framework, and Python's a pretty easy-to-use interpreted scripting language. So together, this makes a fairly extensible and flexible example to build from. As you can see, this application emulates a control panel, and it uses the Mbarx M2M ASD protocol to communicate with the uCMK60. There is some setup and configuration for connectivity with the device. There is a call status reporting here, and there's call control configuration here as well. You can also see there's a section here that reports events from the device. So these are input events from the device that would occur when a push button is pressed on the System Solutions board, and there are corresponding outputs, which in this case would be LEDs on the System Solutions board. There's also a console on the left which reports the bidirectional communication, and a method by which you can actually add in your own messages as you go along, which is useful for debug and test. So what I'm going to do is I'm just going to connect to my uCMK60. There we go, and we'll see the bidirectional protocol on the left, and we'll also see that we've got call status, so I can see that my device is registered. I can see my outputs correspond with the outputs on the System Solutions board, so I'm registered, the network is ready, and I'm in supervised mode, which means that there's a host application. In this case, a virtual control panel is connected to the device. So in previous videos, I've showed you how you can create a simple push-to-call application. I'm going to run the same sort of push-to-call demo again, except what I want to show now is the difference between autonomous mode and controlled mode. In autonomous mode, when I press the push-to-call button, what would happen is the device would automatically call my IP phone. Now when I just reach over and I'm going to press the push to call button, I'll notice instead that my IP phone doesn't ring. Instead, I get a notification of an input event. I get an input event reported here, and the device, the uCMK60, waits for me to tell it what to do. So I can instruct it to call my IP phone if I like, so I'm just going to get it to start a call to extension 3010. And in the background, you should be able to hear my IP phone ringing. I'm just going to answer that call and then just quickly mute it. I can see that I've now got a call in progress. I can see that my external AMP has been enabled. And now I have the options. In addition to creating call control, I have the ability to control some of the outputs on the uCMK60 just by enabling them or disabling them using the turn on and turn off buttons here. So this is useful for applications such as a building system in the paradigm example that we've given before, where you could connect this to a door lock striker plate. I could unlock or lock the door. Or in a healthcare application where I could perhaps turn on or off a corridor lamp. So that's just some of the basic things I wanted to show you that are available using the uCMK60 virtual control panel as a reference implementation. I'm just going to end this call, and I'm going to clear the notification, and I'm going to disconnect from the device. I hope this video has helped you understand how you can use the Mbarx M2M protocol and tools to develop system-level applications using the uCMK60-VoIP board and module. For more information, check out arcturusnetworks.com. We look forward to helping you with your next application, and thank you for joining me today.